Hey, makers and builders, I'm MHD Noor, and I'm so excited to take you on a journey into the world of PLC's programmable logic controllers. These little boxes are the brains behind some of the most amazing automated systems out there. We're talking about systems that can park your car, fight fires, and even fill bottles with incredible precision. Over the next few videos, we'll be diving deep into the world of PLC projects, exploring how they work, and building some awesome systems ourselves. So, buckle up, get ready to learn, and let's automate the world together. Alright, let's dive into our first project. A fully automated multi-level car parking system powered by the magic of PLCs. Imagine pulling up to a parking garage, stepping out of your car, and letting the system do the rest. That's the kind of futuristic efficiency we're aiming for. First things first, we need to understand the layout of our parking structure. We're talking multiple levels, entry and exit points, and of course designated parking spaces. We'll need sensors to detect the presence of a car, motors to move platforms and elevators, and actuators to control gates and barriers. This is where our PLC comes in. It's the control center that orchestrates all these components. Think of the PLC as the conductor of an orchestra. It receives signals from the sensors, processes the information, and sends commands to the motors and actuators, ensuring everything works in harmony. To program our PLC, we'll use ladder logic, a visual programming language that's surprisingly intuitive. We'll create a set of instructions that tell the system how to respond to different scenarios. For example, if a car enters the garage, the PLC will check for available spaces, direct the car to the designated spot, and activate the necessary mechanisms to park the car safely. Let's break down the process step by step. When a car arrives at the entry point, a sensor detects its presence and sends a signal to the PLC. The PLC then checks for available parking spaces on different levels. If a space is found, the PLC activates the entrance gate and guides the car onto a designated platform. The platform then moves vertically or horizontally, following the PLC's instructions until it reaches the assigned parking spot. Once the car is in position, the platform lowers the vehicle securely into the parking space. The PLC then updates its internal map of the parking garage, marking the space as occupied. The process is reversed for retrieving a car. The owner requests their vehicle, the PLC locates it, and the system guides the car back to the exit point, ready to hit the road again. Building this system will involve a combination of mechanical engineering, electrical wiring, and programming. We'll need to choose the right motors, actuators, and sensors for our specific parking structure design. We'll also need to carefully wire everything together, ensuring all components are connected to the PLC correctly. And of course, we'll need to write the PLC program that brings the whole system to life. This project might seem daunting, but trust me, it's incredibly rewarding to see a complex system like this working flawlessly. And with the power of PLCs, we can create truly intelligent and efficient parking solutions for the future. So, let's roll up our sleeves, gather our tools, and get ready to build an automated parking system that would make even Doc Brown proud. Now let's shift gears and tackle a project that's all about safety and protection, an automated firefighting system using the power of PLCs. We all know the devastating effects of fires, and having a system that can detect and suppress fires quickly can be a real lifesaver. Our goal is to build a system that's vigilant, responsive, and reliable. We'll be integrating smoke detectors, water sprinklers, alarms, and of course our trusty PLC to orchestrate the entire operation. Imagine this: a fire breaks out in a building. Smoke starts to fill the air, triggering a strategically placed smoke detector. The detector sends an immediate signal to the PLC, which springs into action. The PLC, programmed with a set of predefined instructions, triggers the alarm system, alerting everyone in the building to evacuate. Simultaneously, the PLC activates the water sprinkler system in the affected area, aiming to contain the fire before it spreads. The beauty of this system lies in its automation. By using a PLC, we can create a system that responds to fire incidents faster than any human could. This rapid response time is crucial in minimizing damage and potentially saving lives. But how do we actually build this system? First, we need to strategically place our smoke detectors throughout the building, focusing on areas with a higher risk of fire hazards. We'll then connect these detectors to our PLC, ensuring that any signal from a detector triggers an immediate response. Next, we'll integrate the water sprinkler system. Each sprinkler head will be connected to the PLC, allowing for targeted activation based on the location of the fire. This targeted approach prevents unnecessary water damage to unaffected areas. Of course, no firefighting system is complete without a robust alarm system. We'll connect a loud, clear alarm to our PLC, ensuring that it's activated as soon as a fire is detected. The PLC acts as the central nervous system, receiving input from the detectors, processing the information, and sending commands to the sprinklers and alarm. Programming the PLC is key to creating a system that's both effective and safe. We'll use ladder logic to define the system's behavior, ensuring that it responds appropriately to different fire scenarios. For example, we can program the PLC to activate specific sprinkler zones based on the location of the fire, or to trigger different alarm patterns depending on the severity of the situation. Building this automated firefighting system might seem complex, but it's entirely achievable with the right knowledge and tools. And the peace of mind it provides is invaluable. By harnessing the power of PLCs, we can create a system that's always on guard, ready to respond to fire emergencies with speed and precision. Get ready to dive into the world of precision and efficiency as we explore a PLC-based automatic bottle filling system. This project is all about creating a system that can fill bottles with incredible accuracy, ensuring consistent results every time. From food and beverage industries to pharmaceutical companies, automated bottle filling systems are essential for mass production. Our goal is to build a system that's not only accurate but also adaptable, allowing us to fill different types of bottles with varying liquids. We'll be using pumps, valves, sensors, and of course our trusty PLC to orchestrate the entire filling process. Picture this. Bottles move along a conveyor belt, arriving at the filling station one by one. Sensors detect the presence of each bottle, triggering the PLC to initiate the filling process. Pumps controlled by the PLC draw liquid from a reservoir and send it through precisely calibrated valves. The liquid flows into the bottles, filling them to a predetermined level. The PLC continuously monitors the filling process, using sensors to ensure accurate fill levels. Once a bottle is filled, the valves close, the pumps stop, and the filled bottle moves along the conveyor belt, making way for the next one. This automated system ensures consistency and efficiency, eliminating the errors and inconsistencies that can occur with manual filling. But how do we build such a system? First, we need to select the right pumps and valves for our specific application. The type of liquid, bottle size, and desired filling speed will all influence our choice of components. We'll then connect these components to our PLC, ensuring that it has complete control over the flow of liquid. Sensors play a crucial role in this system. We'll need sensors to detect the presence of bottles, monitor liquid levels, and ensure that each bottle is filled to the correct level. These sensors will provide constant feedback to the PLC, allowing it to adjust the filling process as needed. The PLC, programmed with ladder logic, acts as the brain of the operation. It receives input from the sensors, processes the information, and sends commands to the pumps and valves, ensuring a smooth and accurate filling process. We can program the PLC to control various parameters, such as filling time, liquid volume, and even the speed of the conveyor belt. This level of control allows us to fine-tune the system for optimal performance. Building this automated bottle filling system might seem like a complex undertaking, but it's surprisingly achievable with the right approach. By combining mechanical components, electrical wiring, and PLC programming, we can create a system that's both efficient and reliable. So let's gather our tools and get ready to build a system that can handle the demands of modern production lines, ensuring that every bottle is filled with precision and care. Now let's step into the control room and explore the power of PLC-based industrial monitoring systems. These systems are essential for overseeing complex industrial processes, ensuring efficiency, safety, and optimal performance. From manufacturing plants to power generation facilities, industrial monitoring systems provide a real-time window into the heart of operations. Our goal is to build a system that can monitor critical parameters such as temperature, pressure, flow rate, and more. We'll be using sensors, data acquisition modules, human-machine interfaces, HMIs, and of course our trusty PLC to collect, analyze, and display this crucial information. Imagine a vast industrial facility with countless machines and processes running simultaneously. Our monitoring system acts as a watchful guardian, collecting data from various sensors placed strategically throughout the facility. This data is then fed into the PLC, which acts as the central processing unit. The PLC, programmed with ladder logic, analyzes the incoming data looking for patterns, anomalies, and potential issues. It can trigger alarms if certain parameters exceed predefined thresholds, notifying operators of potential problems in real time. This early warning system is crucial for preventing equipment failures, ensuring worker safety, and maintaining optimal production efficiency. But how do we actually build this monitoring system? It all starts with selecting the right sensors for the parameters we want to monitor. Temperature sensors, pressure transducers, flow meters, and other specialized sensors will be deployed throughout the facility, gathering real-time data from critical points. These sensors will be connected to the PLC through data acquisition modules, allowing the PLC to receive and process the incoming signals. The PLC, acting as the brain of the operation, will be programmed to analyze the data, looking for trends, deviations, and potential problems. We can program the PLC to trigger alarms, generate reports, and even adjust process parameters automatically based on the collected data. To visualize this data and provide operators with a clear overview of the system, we'll use an HMI. This graphical interface displays real-time data in an easy-to-understand format, allowing operators to monitor the system at a glance and respond quickly to any issues that arise. Building a robust industrial monitoring system might seem complex, but it's within reach with the right knowledge and tools. By combining sensors, data acquisition modules, PLCs, and HMIs, we can create a system that provides a comprehensive view of industrial operations, enhancing efficiency, safety, and overall performance. So let's roll up our sleeves and get ready to build a monitoring system that's worthy of a mission control center, ensuring that our industrial processes run smoothly and efficiently. Well, there you have it. We've explored 4 incredible PLC projects that highlight the power and versatility of these amazing little controllers. From parking cars to fighting fires, filling bottles, and monitoring industrial processes, PLCs are revolutionizing the way we automate the world. Remember, this is just the beginning. There's a whole universe of PLC projects out there waiting to be explored. So, keep experimenting, keep learning, and keep pushing the boundaries of what's possible with automation. I can't wait to see what you create. Until next time, keep automating, keep building, and keep that maker spirit burning bright.